Thank you to Green Drinks Boulder. Thank you to Metro Green Home Tour. Our home is going to be on the tour this year, so I hope everyone signs up. And a special thanks to Angela for bringing her homemade chocolate. Definitely check that out if you haven't seen it. As John mentioned, yes, my firm is called Bari Architecture, which the word Bari in Bengali means home or shelter, which I can credit my dad, who's back there, for helping me name it. Wave, Dad. Okay. This little QR code over here has a lot of links to things I'm going to reference today, so I'll also show it at the end, but you can take a screen grab of that if you want to. And also follow us on Instagram. We love to keep in touch and talk about this kind of stuff. Like John mentioned, I've been an architect for 20 years, but recently certified passive house consultant. So it's new to me. I'm really excited about it. I don't think enough people know about it, so that's why I'm here to kind of help spread the word. Enough about me. Wait, who are you? I would like to know how many passive house consultants are in the crowd. I know at least two. One, Andrew, are you passive house consultant? Tradesmen. Okay, so two of them. So Mark is like OG, has been doing it for a while. He's with Joubert Builders, and he did a passive house retrofit on his own house. So he's a good person to know for sure. How many people are in the architecture industry? Tradespeople. A couple of people here, okay. And then how many of you are homeowners who want to do stuff to your house? Oh, okay, great. That's what I was hoping for, so this is great. Who are we? Like I mentioned, there's another one of me. His name's Tom. He's my partner, so it's a we. There's two of us, and we both used to work at a big firm doing a lot of commercial development. I started this firm 13 years ago. We met studying abroad in Scandinavia, so our style is very warm, modern is kind of what we like to say it is. And we do retrofits, we do new builds, we do a lot of adaptive reuse, pretty much anything. We just finished up our first fire station, but that's a story for another day. For example, this is a project we did recently in Park City, Utah. Our clients bought this home. It looked like this little pink picture you see in the front right there. They bought this home, and the home was super leaky. You could feel the wind blow through it. And they're also in a very high fire-prone area, so they're really worried about, making sure that it's fireproof. The deck was falling apart, so we did a really heavy remodel. We basically added 2 inches of insulation to the walls and the roof, and we kind of wanted to de-pinkify it and make it blend in with the environment a little bit better. And so we ended up with what's on the left over here, which is metal roofs, and we used Moso bamboo for the siding, which made it super resilient to fires, and also it's a pretty sustainable material. And this is a pretty typical project, taking something that's existing and working with it to get what we need. Here's another project we did in Louisville, Colorado. It's in downtown Louisville. It's a new build, so there was no house there. And this was after the Marshall Fire rebuilds. It wasn't part of the Marshall Fire rebuilds, but the city of Louisville had a 50-page document of kind of how to build post-fire in this new sort of landscape. And our goal is always, this has been published in a magazine recently called Modern in Denver. It's in the latest issue. So our goal is really to have high performance, but also magazine award-worthy publishable homes. That's kind of like the ideal. I'm not supposed to say them. So anyway, all of these projects were sort of nudging us in the past 5 years towards really strict energy standards. IECC 2021 came out, and all these fires that are happening everywhere. It was kind of pushing us in this direction of something that we didn't really have to address before. So it's a good thing in a good way. I very much encourage cities and jurisdictions pushing the building environment. So around 2023, as an architect, I have to do this continuing education every year for a lot of time, and as a human being, I put it off until the last possible minute. So I was looking for a conference that would give me the biggest bang for my buck. So the Passive House International Conference was in Denver that year, and I could get 24 continuing education credits instead of the 6 I would get at the American Institute of Architects credits. So I knew this was a good thing. I knew, there was going to be some good material there. So that's really where I kind of caught the bug and went down this passive house path. So what are we going to cover today? We're going to cover what is passive house? What does it mean? What are the standards for new construction? And what are the standards for retrofit? Which you kind of have to know the new construction to really understand the retrofit. And then we looked at our house through the passive house lens because realistically, most of us live in existing houses and there are limitations to what we can do. So this is a video, I'm not going to play it. Basically, the passive house standard was invented by Dr. Faust in Germany in the 1970s, and he was a physicist who determined that if you insulate a building well enough and get rid of all the thermal bridging, you can basically get to 90% of energy independence, and then the other 10% can be produced by human beings and appliances. So the goal is to have no HVAC. That's the ideal standard. And some of you who are a little long in the tooth, Kirk, might think that passive sounds a little familiar. And didn't we hear about this back in our green design lecture, the one we had in architecture school, something about thermal gain and ventilation? This is not the same thing. So passive solar is a different thing. And I know there's a lot of passive solar homes around this area. It's a great model, but that's not what we're talking about here. Passive solar was a bunch of strategies that you could use to passively heat and cool your home. Passive house is based on 5 very specific principles that lead to a certain result. And it's measured, so you have to hit these metrics. The passive solar world was not measured. It was sort of like, hey, you could try putting more windows here and fewer windows there. In general, passive house uses 90% less energy than a conventional building. LEED, for example, uses 30 to 60% less. So just to give you an idea of how intense of a standard it is. If you're familiar with the HERS index, here's your conventional building at 150. Here's your LEED building around here, I think. Talk to Ellen if you have LEED questions. She did a LEED Platinum retrofit for her house. And here's passive house way down here in the green happy zone. So 90% less energy usage is the goal. And it's always these 5 principles: super installation, airtight construction, high performance Windex, energy or heat recovery ventilation, and minimal mechanical systems. So airtight construction. I love this diagram at the bottom because what we're doing right now is we're digging up fossil fuels, we're generating energy, we're sending them through high voltage wires, lots of miles, hundreds of miles, to get to our home, to heat and cool our home, and then we're just letting it leak out of our house. Like, that's so disrespectful to the coal, like this is a lot of distance to just let it leak out of your house. So airtightness is very important. And the way you kind of deal with airtightness in passive house is you do the blower door test. Some of you might be familiar with the blower door test. It's where you close all the windows and you put this fan in the door and you pressurize your house and see how many times an hour does your house leak air. So just as an example, building code right now is 3. So you're allowed to fill up your house, heat and cool it completely 3 times an hour at this pressurized rate. This airtightness model didn't show up until 2012 in the building code. So see how much harder it is now for us in 2012? So in passive house, the number you have to hit is 0.06. So it's basically saying that you should have to only heat and cool your house 1 time in 24 hours. You can't just let it leak out. And the plus side is no spiders, less bugs. Super insulation. So here's a picture on the right side of something that would be very typical for a passive house. In Colorado, 18 to 24 inches thick of insulation is not uncommon, right, Mark? Like, that's pretty. And a double wall construction, 2x4s. How many 2x4s do you guys have on your exterior? Usually one. So 2 layers of 2x4s and 18 to 24 inches of insulation. On the left is a picture of a retrofit where people added it's called a Larson truss to get that thickness to work. Minimal mechanical systems. So the mechanical systems are really meant to just add a little heating and cooling when necessary. It's not meant to keep you going. So the location and the design of the mechanical systems is really critical to be as minimal as possible. You'll notice we're only exhausting from the bathroom and the kitchen. We're not supplying in there. So there's really tight numbers of how much air you can supply per occupant for the house. Windows. There's windows and then there's passive house windows. So passive house windows have to be super thermally efficient in themselves, in the frame, and the glass, and the spacers and everything, but also the installation of the windows is really scrutinized. You see this diagram on the bottom left. It's showing how there's no cool coming through the window. You want to keep all that cold air out. And it's hard. Thus the beautiful mind. Heat recovery ventilation. I had never heard of this term, but this is a tool. This is a piece of HVAC equipment that brings in fresh air. You might be wondering, when your house is so tight, do you have issues with mold and fresh air and all this kind of stuff? Homes were designed to be tight back in the day because you were burning fire for fuel and gas. Now you don't need that as much, especially if you go all electric. So you use an energy recovery ventilator or a heat recovery ventilator to bring in fresh air intentionally where you want to, clean and purify the air, what a concept, and then also transfer the heat to your old, so you've already heated and conditioned the space, you're bringing in fresh air so the air is fresh and then gets heated by the heat transfer through this machine. So this is a pretty important part of it. And then the last part is the energy model. So Woofy is this German model, and you model everything. You model, if you're doing 2x4s at 18 inches on center with Douglas fir, remember this was invented by a physicist, so you want the thermal properties of that type of wood at that depth to be modeled in here. Are you doing a 1/2 inch of gypboard, or are you doing a 5/8 inch? All of that goes into the energy model, so you know exactly ahead of time how this house will perform, and then you have to build to the standard to get the certification. Are people actually doing this? Yes, not just houses, schools. This picture on the left, sorry it's so small, it's a whole development in Kansas City that's passive certified. So people are doing this at a really large scale, and it's totally possible. The picture on the left bottom is a school in France. I think it looks pretty cool. The house on the top right, also a cool house, and it's all passive. So people are doing it. What are the financial implications? They say 3 to 5%, but I just do pretty pictures. I don't get into that, so ask Mark. There's also a lot of incentives because the passive standard is so well respected. You can see Xcel Energy rebates. They offer, this is after the Marshall Fire rebuild, so they were offering $37,500 in rebates for a passive home. The next level down was an Energy Star Ready certified home for $17,000. So over double for a passive house because they want you to do this. And then people love it. People love living in these passive homes. They're always saying the air feels fresh and clean, no spiders, it's so quiet, and the house is always the right temperature. So people like living in them too. So this is all great, but most people live in homes that are already built, right? What are we to do? So there's a couple things you can do. You could do what's called the deep energy refit or a shallow energy refit. I don't know if it's called this, I'm calling it. So a deep energy refit is where you're building to passive standards And it's a big project. You know, you can add, like I said, the Larson Truss to get your 2 feet of insulation to your existing house. I think if you have siding versus brick, you're better off, you're more set up to do this. But people are doing this where they're adding all this insulation, they're adding roof insulation. And the one reason to use the passive standards, you know, you don't have to get certified. It costs money to get certified, several $1,000s, energy modeling. But this holds your feet to the fire, and it holds your subcontractors, your GC, it holds them all accountable to meet these performance metrics. So that's one reason to get it certified. Even with brick, don't everybody gasp at once at the picture of the insulation over the brick. I know people yell at me for painting brick, so, but you can insulate over brick. But I would highly recommend having the Wolfe passive model done so you're making sure that the wall is performing accurately and moisture is not getting trapped in the middle. But these are things that, once again, people are doing it. And the perfect time to do it is when you're doing a pretty heavy remodel. If you're gutting a house, if you're doing something big. So on the left side, you can see they added a 2nd floor. If you're doing a remodel and you're thinking about changing the character greatly. These are on the right side are also remodels. So it doesn't have to be modern. I know everybody doesn't like modern. I like modern, but it can be something a little bit traditional, but it doesn't have to look like something different or, you know, not conventional. You also have to update all the mechanical systems. So for a deep passive house retrofit, you basically do the envelope and then you do the guts. And it is an invasive process. As you can see, it will have a big impact. You're going to take all your siding off. You're going to have to move out of the house. It's not like an easy process. What about commercial retrofits? Absolutely. This is a 100-year-old building at NYU's campus. It's a housing dorm, and they achieved passive house standards. And you can see how they did it. It wasn't easy, but they did it, so it's totally possible. And it's brick. The other option, like I mentioned, are shallow retrofits, which is basically an energy audit. So you can go to Excel, find the right, it's like hitting the easy button. You can go to Excel, get the right qualified contractor. It costs about $600. There's still energy rebates, $200 through Excel, $150 through the taxes until the end of this year. But you can totally, everyone should do this. This is sort of the shallow energy. And usually what this entails is adding insulation to the easy areas. But plot twist, there's a new system that just came out last year, and it's called FIAS Revive 2024. Have you guys, the 2 CPHCs, have you heard about this? Yeah, you have. Mark, of course, he knows. So this standard came out for people, especially like us, who don't want to do the deep energy retrofit, but the shallow doesn't, is there something in between? Can we look at it a little differently? So this has slightly different priorities. There's 4 priorities, and the first one is looking at resiliency differently. So we're past the point of all the climate change scaries. We're living in it. We're in climate change right now. There's floods, there's fires, there's weird spiders. There's stuff happening. So the question is, will your home survive spiders and climate change? So there's a pass-fail metric to this certification where you have to make sure your home can survive 5 days in extreme heat and extreme cold. So you put your house and all the insulation through the test and it's pass-fail. Will you freeze to death in your home? Or will you, so you want it to be well enough for that, and that's something you model. And ideally, you also have resiliency, thermal resiliency, and also grid resiliency. So the solar, the battery, all that stuff helps make your home more resilient during a climate crisis. And that's 25% of the effort. Decarbonizing, I know in the past it's been optional to kind of get rid of the gas, and it's not less optional now. It's just you can phase it out. You don't have to do it all right away. It allows for what happens if I change my furnace 5 years instead of 2, and is that beneficial now? And it wants you to be prepared for when your furnace does break. If you have a 20-year-old furnace, you know it's going to break. You've got 3 quotes lined up, and you know exactly who to call, and you're ready for decarbonizing. Because without decarbonizing, we're not going to meet our greenhouse gas emission that we need to miss. So it's hard to say, put in a gas furnace or a range right now. And then a new thing is no toxics. So there's a spreadsheet you go through, and the idea is to make your home as healthy as possible. So you go through this extensive list and make sure that you don't have lead, asbestos, mold, mildew, and sort of go through the ideal checklists and standards to make sure that your home is safe, because we spend 90% of our time in our homes. And then the air tightness and insulation is part of the equation, but it's not as rigorous, because it's hard to achieve in a retrofit. The air tightness is really hard to even get to 3. I think for my house, the standard is 5 ACH 50. So building code is 3, and according to this, it's not as important to have the air sealing and the insulation as it used to be to get those past few standards. So that brings us to our house. We live in a 1950s brick ranch. We've got brick on the outside and CMU on the inside. There's really no way to do insulation, or we don't really want to do insulation because there's plaster and it's beautiful and it's crown molded. And we started doing some stuff to it, but we wanted to really take a step back and see, could this be a passive certified house, and what would that look like, and should we go after passive certification, especially since this new model came out that seems to be a little bit more achievable. And before we started this, we did solar panels. We did solar and battery because of that source energy thing I was telling you about. Our home is just really well oriented for solar, so we went ahead and did that. And then I went through the workbook. So one thing I really like about this standard is you can go on the website, and all of this is open source. So you can download the workbook, you can work through it, you can get it certified, or you cannot. The software is downloadable. The software is all open source. If you want to put yourself through that kind of hell, I tried. It did not go well. So I would suggest hiring an energy modeler, but it's all open source. And it did kind of influence what we wanted to do and in what order. So we're still going to do all the things, air sealing, insulation, but we might change the order. But the short answer is no, our house cannot be passive certified without doing the walls, is kind of what we determined. So I'm going to save my money for our next house, which will probably be a passive certified house. But in conclusion, if you can build a new house, consider passive. If you can retrofit, do what you can when you can. But at the very least, please do an energy audit. If 50% of people in Colorado did the energy audit, we could basically retire one entire power plant. That's what I have. Remember, it can be beautiful and sustainable. Thank you. Should we take a few questions?
I'm curious about how do you go about doing retrofit in places that or houses that have been kind of designated historical landmarks or things like that?
You totally can. That NYU building was a historic landmark building, so it's totally possible. Yeah.
Are there loops you have to jump through with the city or anticipate loops and things like that?
Generally, most cities are very open and welcoming to all of these systems. So as long as you can show with the energy model that you're not making it worse, you're not damaging it by trapping moisture or something like that, cities are very familiar and open to energy retrofits. Yeah, go ahead.
Historical preservation requirements typically don't you alter the exterior, so you can do an interior curved wall upgrade. So you lose a little bit of square footage, but you can upgrade the insulation by reducing your wall size.
That's a better answer. Yeah, Michelle.
So I want you to address the thing with painting brick, which I can't stand. But recently did cellulose and blew it down through the 1954 branch. Is there a benefit to one or the other? To me, the brick was meant to be brick, but the insulation to me is key.
Yeah, no, I think insulation is great. Blowing in insulation to the brick is great. Brick is meant to breathe, so as long as you're letting it, the type of insulation isn't foam and you're not sort of blocking. Yeah, so it's great. I haven't considered doing that, but
Okay.
Yeah.
It was 19 for us. But anyway, it's cool.
good point. Yeah, Josh.
I was wondering about climate zones. So, like, if you're talking about extreme climates like Alaska versus Phoenix, Arizona, something like Florida where it's humid, like, does that affect like passive home design? How so?
It totally does. And the passive home standards are designed per climate. So somewhere like Phoenix, there's historical data back, I think 100 years or 500 years of weather data that you put into the model, and you run simulations of the hottest day in Phoenix. You also chart the hygraphy of these areas. So some areas have more humidity and they need to be dehumidified. Some places are super dry. So the modeling is where the WUFI modeling is where all that plays in. And Passive House started out in Europe, and there's a branch of it called Passive House US, which is specifically designed to address that, because Europe kind of has a lot of the same zones. The US has Alaska down to Florida, and they have a little bit more specific requirements for the different zones. Yeah. Yeah, John?
Yeah, not so much a question, but like two things I want to observe or throw out. One is the building at New York University is pretty darn impressive. That's a big building, and now we learn it's historic as well. A lot of my work is actually in California and Washington, but I work with architects and I work with developers on energy-related things, and I thought this was so cool. It's under construction now, but I want my company to make a national case study of it. So Habitat for Humanity of Olympia, Washington, is building 3 related multifamily buildings. One is for kind of like larger families, one is for like couples, and one is like for singles. And I can't remember the unit count, but it's probably like 100 units. It's a big 3-building project, and they're building to passive home standards for Habitat for Humanity.
That's great. Wow. That's awesome.
The second thing was, there was a New York Times article I read about 2 months ago, and I can't get a piece of it out of my head. And the article was about the trend towards electrification, which is a good trend. And one of the things that it talked about was the like indoor air quality. Mm-hmm. And that the analogy that was used is you would not wake up in the morning and spend 15 minutes cooking eggs over the tailpipe of your car. Mm-hmm. But that's similar to what you're doing, because you're between the fire and the exhaust. And so that's similar to what you're doing. So I thought that I can't get that out of my head.
Totally. And you mentioned something that reminded me, if we're wondering, is this possible? Massachusetts as a state has adopted Passive House as their building code, the entire state of Massachusetts. And the way they did it is they transitioned into it from 2017. They kind of led people into it. They offered a lot of training purposes for tradespeople and stuff. So the entire state of Massachusetts can do it. I think it's the future. I know the situation right now is dire in the federal government, but I really think passive is the future. Yeah, Ellen?
Can you explain the difference between net zero and passive house?
Yeah, so Passive House is designed to use less energy overall through the insulation and all those designs. You don't have to be net zero to be passive. So you don't have to have solar panels to be passive. You just need to meet all those performance requirements. Net zero is just, you can use all the energy you want as long as you're producing enough, you're considered net zero. Carrie?
Hey, Bonnie. Nice to see you.
You too, it's been 20 years. So.
We worked at Gensler
Yeah.
together. We were both doing huge commercial design. Now I do architectural design for homes also. And the
She does
direction-
earthships and very sustainable things,
Yeah,
so.
so the direction I went was more natural and alternative, and I looked into Passive House maybe like, I don't know, 5 to 6 years ago, and I was kind of turned off by how much foam and how much plastic and just like EPDM, and it was like everything, to get the air tightness, it seemed like they relied heavily on non-natural materials. But then I have heard since then that it's gotten a little more friendly towards natural materials. So I was wondering, when you went through the certification, did you see, like, what was your take on it?
Yeah, that's a good question. It wasn't really specifically addressed to avoid foam use, but at the Passive House conference and in most of the conversations, foam is just considered bad. Mineral wool and more natural things because of that air quality issue. But there are some times where you just have to use foam, especially when you have designs like cathedral ceilings, and it's really, really hard to avoid. So it's good to kind of, if you decide you're gonna do passive early on, you would avoid doing the cathedral ceiling, which would avoid doing foam. So the reason the walls are 2 feet thick is because you could do it much thinner with foam and all kinds of stuff. So it's not part of the rules, but it is encouraged to use less unnatural materials. And my whole goal is to, most of our clients, as architects, I want to affect all the non-natural, people who are building something natural and sustainable, they're going to do their own work. But most of our houses are builder homes from the 80s, and that's the kind of audience I want to approach and get more massive change. So that's why I'm sort of like, if it's spray foam sometimes, that's okay. So that's kind of how I approached it. But in general, there's sort of a underlying sort of no about foam. Yeah.
I might mention that your new Revive is much more similar to a larger array of criteria for LEED. So you mentioned that LEED was between 30 and 60, but it can be net zero. So it's just the standard for the air exchanges is based on balancing that with low energy use. So it's got a kind of a different emphasis, but I'm glad to see that Revive is creating that healthful living environment. So there's a lot of emphasis on clean air and low emission products, and like I use rock wool.
Yeah. So Ellen did a LEED retrofit of her home, and she has a blog about it, Twin Springs blog, and she documented it. Carrie and I both worked at a really large firm that would design a giant glass skyscraper, slap a LEED stick. Stop me if I'm wrong, but it was kind of an afterthought. I mean, those of you in the industry know the green label is often a little bit of an afterthought. So I was pretty turned off by the way green building was back then. So I really appreciate this whole performance metric of just using less energy from the get-go and really having it be part of the design. Yeah, go ahead.
Where do you see passive house construction going in terms of bringing the economics, affordability into reach for more and more people?
Yeah, that's a tough one. Does someone else want to answer that?
Sure, I'll talk about that a little bit.
Yeah, Mark.
So you mentioned in Massachusetts, they adopted passive house as their building code for buildings over a certain size, not for every single building. But what happened is when they started addressing the economics of it, they actually found that it was actually when it's designed into the process, it's actually cheap. It was actually cheaper for those buildings to build passive house than for the code for a number of reasons. But to address economics, you have to address it from the design standpoint. There's a lot more upfront design intensity in passive house in order to address some of the economic concerns and also some of the detailing concerns that filter down into the general contractor and the subcontractor.
is that just because it's new?
It-
Is it more expensive just because it's new and it's not readily available to people?
Well, it's been around since 1999, right?
Well,
So it's
okay.
not, I mean, it,
But it hasn't been scaled up, I guess.
well, yeah, it hasn't been scaled up. It has, there's a lot of factors involved, but the 3.5% is probably about right. And it just depends on how you look at that from the economics of the specific project on the payback of that. But generally, it's less, we're to the point now that it's less than a 10-year payback on that. And it also has to do with the fact that, there's some contractors here. New isn't always the friend of the contractor, and so they will put in a fudge factor there to cover themselves potentially. So that's again why upfront design and upfront coordination with a design team is really important. You can't lay this stuff on top of it after the fact, and you need your engineers, your MEPs, your architects, and your consultant on board immediately and working together from the beginning, or else you will see scope creep, you will see cost increase.
Yeah, Mark?
Well, getting back to the subject of economics, one of the things that I've heard recently is that to reduce housing costs, there's a big push towards building modular houses. So building houses somewhere. It seems like if you have a lot of engineering that has to go into the housing, that makes a lot of sense. You do the engineering once for design and replicate that in mass production. It's really saved a lot of money. Do you have any thoughts on that?
Yeah, totally. There's several companies. Be Public is one that's local to Colorado. They're on the edge of Colorado, New Mexico, and they have a prefab system where you can go and build your sort of kit of parts. I think they're $350 a square foot right now, plus site work. So modular is a great way to do it for sure. And then just from the sort of overall, this is not business as usual in the residential world or the commercial world. So I know there's some people who are frustrated where they want to do the green thing, but their architect or their mechanical or their structural, like they're just kind of like, what do you mean? Why do you want to do a heat pump? Just do gas. It's easy. There are people, the marketing team is not so big. I don't think there is one at Passive House International, but there are people who are really passionate about this. And Colorado has a lot of great resources, but you do have to find the right person. And if you find one person, then they'll introduce you to the other people. So there's prefab, there's modular. Colorado, I think, is a pioneer. That's why that conference was here. There's a lot of great resources here, so there's no reason for you to feel frustrated about I want to push the envelope, but my HVAC contractor or my insulation guy is just not the right guy. And it's much easier to do the same thing over and over again. I don't know if that answered.
Yeah.
Yeah. Steve.
Can you speak a little bit? I know this is broadly speaking in various cities, city to city, but can you speak a little bit about the kinds of code that either facilitate or get in the way of this type of building?
Totally. So I was, okay, I think it's dead. Uh-oh. I was just talking to Josh about this, actually. Denver has one of the strictest codes, as you guys know. They kind of went from 0 to 100 overnight and said, no gas, all electric, whatever. And people were like freaking out. And now they've gone back to allowing a little bit of gas backup. So Denver was definitely a code that pushed our limits. They tried to do too much too fast, and it was not ideal. And so now they've backed off. But because because the cities pushed us, I decided to go get this more information. And I really think the only way for this to happen is for the jurisdictions to push and make people get out of their comfort zone. The Home Builders Association, I hope there's no one here from there, has a huge lobby, and they have petitioned to ease back on these strict code requirements. So they're putting a lot of money into it. The FIAS people, you see us, we're wearing Birkenstocks. Like there's no lobby, for the passive house thing. So the cities have to be the ones that implement it. And Colorado being really, it's cold in some places, it's dry, it's a complicated climate, is a great place to push it. And there's ways for people to get there. Massachusetts got there. They did it slowly over 10 years, I think. So it's totally possible. So Denver's a big one. What else do you think? IECC 2021 was huge for everybody. That was the most strict. This air tightness thing that I mentioned, where you can only have it happen 3 times a day, that only showed up in the code in 2012. Before that, there was
In whose code?
the International Electric Conservation Code. So before that, there was no requirement to make a building. 2012, that's like, in the 2000s. So some of these are really new things. Yeah, Tim.
If I can just add to this, being an old guy and having worked at Rocky Mountain Institute with Emory Lovins when he built his house up in basalt or old stone house, he put the solar on and the power company said, okay, fine. And he said, well, I'm generating more electricity than I'm using. And he had to take them to court, and it had to be a legal decision. So what I'm suggesting is it's individuals who are fighting for the right way of life that are going to make the difference here. And there's going to be lobbyists that push against this, and that's fine. We need a brake in a car. We're going fast, and we need the brake to slow us down when we do too much too fast. But it's individuals who say, I'm going to do this, and how can I get it done? And we've got to navigate, and that's the beauty of
And New Energy Colorado, who's sponsoring this event, had a huge hand in getting the Excel rebate. So there's people in this room who have gotten us where we are. They're the reason you're getting $2,000 off your heat pump. There are human beings here in this room who helped get to that. So, yeah. And those rebates are not going away. So the federal rebates are going away, but the local Excel rebates are still here. Yeah, Dave.
Triple.
They're triple.
I was going to ask, other than the blower door test, is there like a follow-up energy verification on achieving 90% reduction to get the passive certification?
I know that there's a third party that does the verification. So there's the architect who can be the passive house consultant. There's the builder. There's a third party verifier after the building's.
There's a certifier. So, it depends on which program you're running through, whether you're running through international or whether you're running through FIAS. There's 2 different paths you can take. But the certifier has to be a third party. It can't be out of the same organization. So the consultant helps, work with the design team, work with the construction team to kind of detail it out. I like to say that passive house is a design standard because everything on the plans, if executed, means you're passive house because it's already been modeled through the design, right?
Yeah. So it's not like,
the door
yeah.
test is really truly the only thing in the field, and then there's photo and video verification to make sure that the details that were implemented in design were implemented in construction.
David Lynn Weiss.
Dave. Anyway, I'll just interject a few things because we work on a lot of historic houses and then kind of also look at in terms of deep urban historic preservation. It's the counterforce of success. But anyway, first of all, I think it's important to remember so many of you are trying to fix how you do things at home. Only certain things require building permits. Only certain things require general contractors. I'm generally concerned, as you all know, probably about society's drift away from being able to do a damn thing for themselves. And so you should assume you're quite empowered. You all made it through, probably everyone made it through 8th grade science classes. So there's stuff you are capable of doing, first of all. So keep that in mind. Why can't I do it? Or someone I trust, why can't I have them do it? But with historic buildings, it is tough in central Denver. I'm proud of our landmarks commission's help on that it can be designed. Remember that attic insulation is by far the most economical, effective thing to do to save energy in historic brick masonry houses.
You can call someone, you can rent from Home Depot, blow it in, it's not fiberglass, it can be cellulose, it's not toxic. Anyway, there are things you can do. Secondly, there's this massive culture war over windows. And if you watch television, you will assume you shouldn't, but if you'll notice, other than buying a pickup truck, windows are the most aggressively marketed thing.
Yeah.
We're bombarded with on an hourly basis. At any rate, we're not allowed to replace certain windows in a landmark district in Denver, but you can call these nice people in Iowa, they will make wood storm windows, which you probably put on the clips that are still on your historic house from when you used to have storm windows. And you can have double pane storm windows. So by the time you properly maintain and repair a double hung window, whatever, which you can do yourself, you have a sawhorse and a scraper, you can make your old windows quite functional if you learn to prime, paint, sand, none of which requires a permit. And then you can put storm windows on. You hire a strapping young person to take them off in the summer and put them on in the fall. And they need the work. So windows, storm windows, attic insulation, and I learned this late in my career. One of the greatest heat losses out of our brick masonry homes in central Denver is the top third of your basement wall. Nobody thinks of that. I didn't think of it for decades. And you can insulate that, some not to passive house standard, but quite effectively on the interior. And then you dry all of it. It can be, just that much, but it really does save a tremendous amount of energy. And the final thing I learned the hard way is you have an old gas-fired boiler, it's really just a water heater, we don't use steam anymore, and beautiful radiators, radiant heat. Don't tear it out. You can put your heat pump system on your house, and the boiler acts as a backup in the really tough period of the winter when the heat pump might not be able to keep up because your house isn't that well insulated because of brick masonry. But you use a little bit of gas in extreme conditions, and you save all the asbestos mitigation and all that freaking out, all the sadness of watching the beautiful boiler. At any rate, I mean, not just saying clear thinking.
Totally, yeah.
Embracing clear thinking. What can I do myself? What can I do without a lot of
Yeah.
regulation for someone I trust?
Yeah.
And what is the cheapest approach? And then now I've learned also you have to look at the lifespan. What is the payback? I do this math all the time now. Car buying, furniture buying, so I got I'm going to have this in a few years. Think it through in terms of your own life and so on. And we can do the next generation, of course. But make a sensible decision, start saving energy today, because every day you miss, right, is a loss.
Yeah. On that note, I think we have a lot of great people and resources and minds in this room, so I think maybe we can let you network. And, oh, sorry, did you have one more, Steve? Make it good.
My last question, like if, say, you had the ear of the building official that said what kind of code would facilitate this type of certification?
I think helping with the awareness and getting the word out that there are other standards than IECC, and education and job training. I know there's a lot of scholarships for people who want to get passive certified and tradespeople. So just helping get the word out and helping providing the resources and doing that transition instead of overnight. We're going from 2012 to 2024, stuff like that, and just sharing information, because I think people are just sort of like stunned at what to do next and how to get educated. And we're really going from, heating is like, 2000 BTU at the source that ends up being 75 degrees by the time you use it, to really sophisticated systems that you need an electrical engineering degree. Like, that's a hard transition, and it's going to take a long time to make. So making room for all of that. This transition is the best way to do it, I think. Okay, thank you all.